Welcome back, everybody. This is our video solution to problem 2 from Superquiz 3. And here we're looking at sequences again. So we're given two different sequences, and we're asked to compute the limit, if they exist, of these two sequences. So this first sequence, let's see, we have 1 and then 1 plus a third, and then 1 plus a third plus a ninth, 1 plus a third plus a ninth, plus a 27th. Right, each time we're taking the previous term in the sequence and we're adding another term. And let's see, what are we adding? So we have a third, then we add a ninth and a 27th. These are powers of 3, right? 3 squared, 3 cubed. So the nth term of b is going to look like a sum, right? Because we're adding things up. And we're adding up powers, right? So say kth powers of 3. And k is going to run from 0 to, okay, well, if that's the 1, the 2, the 3, yeah, like 4. Okay, so it'd be whatever the nth term is. Okay, now we want to know the limit of this sequence. So the limit as n goes to infinity of b sub n, well, that's just going to be the series, right? This is the series. K goes from 0 to infinity, 1 over 3 to the k. Or if you prefer, and I do, I can pull this k exponent out because this is the same thing as 1 to the k over 3 to the k, and 1 to the k is 1. But this is a geometric series. So this is a geometric series with ratio 1/3. Okay, and of course 1/3 is less than 1. So we know that the sum of this series, right, which is actually just the value of the series, is 1 over 1 minus a third. Okay, 1 minus a third is 2/3. So we invert 2/3 and get 3/2. Okay, well, that's what B converges to. How about C? Now, oh my goodness, C looks devastating, right? All right, you have all of these 1/2 powers. So there's a few ways that you could attack this. One is to start factoring out some stuff. Another is to say, well, man, maybe there's something I could, I don't know, multiply this by. I don't know, get rid of these powers. Okay, that method maybe isn't where you want to go here. So let's try the first method, right? Let's try factoring these things out. So in the numerator, the relevant term, right, is always going to be the highest power of n, so that's the n to the 5/2. And in the denominator, it'd be n to the 7/2. So what I'm going to do is look to the lower of those two powers, in this case, in the numerator, and I want to factor that out of the top and the bottom. So I'm going to take 2 plus n to the 3/2 plus n to the 5/2 over n to the 1/2 plus n to the 7/2. And I'm going to rewrite this by factoring out a 5/2 power. So I'll be left with 2 over n to the 5/2 plus, okay, when I get rid of 5/2 from 3/2, that'll be negative 2/2, which is negative 1. So 1 over n. And then I have plus 1. And I factored out an n to the 5/2. Okay, in the bottom I do the same thing. All right, I'll factor out an n to the 5/2, and what's left over? So let's see, 1/2 minus 5/2 is negative 4/2. So that's going to be 1 over n squared. And then 7/2 minus 5/2 is 2/2, which is just 1. So this will be plus n. All right, now these are going to cancel, all right, because my n is starting at 1, so n is definitely not 0. So these are going to go away. And I'm just left with 2 over n to the 5/2 plus 1 over n plus 1 over 1 over n squared plus n. Now, ultimately, I want the limit as n goes to infinity. Well, what happens? As n goes to infinity, 2 over n to the 5/2 is going to go to 0. 1 over n is going to go to 0. 1 over n squared is going to go to 0. So what's left over? Well, okay, I have this 1. That's just a constant. So this numerator is going to get closer to 0 plus 1, which is 1. And in the denominator, I have this piece going to 0 and n going to infinity. But if the fraction's numerator goes to a constant and the bottom is going to infinity, then this fraction is going to converge to 0. Okay, and of course we're just repeatedly using this given fact, okay, which we actually proved in problem 1, but even if you didn't, you may use this fact. Okay, so there we go. We've been able to determine that both B and C converge and what they converge to.